Hi, everybody. We're going to talk about solving with cofunction identities and finding some values of special angles. Go ahead and pause so that you can write this down. Last time we met, we learned that cofunctions are complementary. So when you have two angles that are cofunctions, what you can do is you can set their angles equal to 90 because those are complements, and you can solve. So what I'm doing is I'm writing out the two given angles. I'm going to set them equal to 90, and then I'm going to solve this algebra equation. So go ahead and combine your thetas. Theta plus 3 theta. 4 plus 2. And then I'm going to bring down 90. This is 90 degrees, but I'm just going to write 90. Okay, the next thing I'm going to do is solve this two-step equation. Subtract 6 from each side. And of course, at the end, you want to divide by 4. So 84 divided by 4 is 21 degrees. Now, there is a way that you can check this answer. All you have to do is plug it back into the original equation. So if I put 21 degrees back in here, 21 plus 4 is 25. And if I put in the 21 here, that's going to be 63 plus 2 is 65. By definition of cofunction, cofunctions are complementary angles, so these two should add up to 90. If you add 25 plus 65, it does equal 90, so your answer checks out. So take a look at example 2. Go ahead and pause and write down if needed. The first thing I'm going to do is identify the angles. So I'm going to go ahead and write out my angles. 2 theta minus 18 plus theta plus 18, and of course this is degrees, equals 90. These are cofunctions. Tangent and cotangent are cofunctions, so they're complementary. I'm going to add up my like terms. 2 theta plus another theta is 3 theta. Now look at this, negative 18 plus 18. That's kind of an interesting situation. Negative 18 plus 18 is equal to 0. Those are just going to cancel each other out, cross out, and you still have the equals 90. The last step would be to divide by 3, and theta equals 30 degrees. Not every one of these problems is going to work out as a whole number. Some of these are going to be fractions. If they're fractions, leave them in their lowest form, so reduce as much as possible. The other thing that you're going to notice is that not all of these questions are going to be theta. Some of them are going to have alphas and betas and so forth. When you're writing out alpha, remember, if you have a hard time writing it, you can just write an A with an extra tail, or you can just freehand it and do the alpha that way. So I just do the freehand alpha. Again, it's just another Greek letter. Okay, identify your angle and write out your equation. Combine your like terms and solve. So go ahead and try this one on your own, pause if needed, and then verify your answer when you've got it done. If you did it correctly, you should have gotten 12 degrees. And remember, if you want to, you can always take 12, plug it back into your original angles, and if the two sides add up to 90, then you have your answer correct. The other type of thing we're going to look at in today's lesson are these special right triangles. There are 2 of them. We have a 30, 60, 90 and a 45, 45, 90. So we're going to write out an example of each. So the ratios of the sides of these triangles are going to be very important as we work through these upcoming sections and chapters and so forth. In these triangles, our sides are always going to be in the following ratios. Your shortest side, the side opposite the 30-degree angle, will always be the shortest side. And what the book does is that they just use the letter X to represent your shortest side. The hypotenuse of this 30, 60, 90 triangle will be twice whatever that shortest side is. So for example, if this is 7, then the longest side, the hypotenuse, would be 14, 2 times that. The other side is going to be whatever that shortest side is times the square root of 3. I didn't make these up. This is just the relationship of the side ratios, the proportions of the sides, and this is found using the Pythagorean theorem. You can do the same thing for a 45, 45, 90 triangle. In that one, your sides are in this ratio. Since these two angles are congruent, then the sides opposite are also congruent. So 45, 45, those sides will be equal. The book just again uses the letter X. You could use whatever letter you want, N, P, T, and this side is also the same. So if this side was 4, then this side would also be 4. The other side then is X, whatever that number is, times the square root of 2. So it's slightly different than this triangle, and again, you could verify this by doing the Pythagorean theorem. If this side was 10 and this side is 10, this side would be 10 times the square root of 2. And that's all derived from the Pythagorean theorem. So this is example 2 from your book. We're going to copy this into the notes, and we're going to find these missing sides. So what I have here is the given information. I just copied this right out of the problem. You should too. And I'm going to start by finding sides that are missing. So I'm looking for A, M, N, and Q. I'm going to start with the only side that is given. That is this side over here, which is labeled as 7. And what I'm going to do first is I'm going to highlight this triangle so that I can see the triangle that I'm working with. So I'm actually working with this triangle over here on this side. If you look at the angles that are given, this is a 60, this is a 90. So this one would have to be 30. This is a 30, 60, 90 triangle. Okay, so what I'm looking for is this backside length over here, not the shortest, not the hypotenuse, that other side, and it equals 7. If you look at our chart over here, that backside of the triangle, not the shortest, not the hypotenuse, is X times the square root of 3. So what I can do is I can set this number that is in that triangle side equal to X times the square root of 3. If I need to get the X by itself, think about algebra. X by itself, I'm going to have to divide by whatever's next to the X. So I'm going to divide by the square root of 3. Now, you know that 7 does not actually divide by the square root of 3. So what you have then is 7 over root 3. But that can be simplified. We've been working on simplifying these expressions, and in order to simplify it, you're going to multiply it by square root of 3. 3 times 3. The square root of 3 times the square root of 3 is just going to give you 3. And in the numerator, 7 root 3 stays. What I just found is that value of X, if we look back here, X was just representing the shortest side of this 30, 60, 90 triangle. So in this case, we're talking about the shortest side. That would be side M. So side M is 7 root 3 over 3. The next thing that we can find is side A. So let's go ahead and find side A next. Side A is your hypotenuse, and according to this, the hypotenuse is twice as much as what we just found for this smallest side. So we're going to do 2 times what we just found. So we're going to take 2 times what we just found, which was 7 root 3 over 3. Okay, now how, and this is going to be side A. So we're finding A, the hypotenuse. Now, how would that work? Well, if we're taking a whole number and we're multiplying by a fraction, I'm going to make this 2 into a fraction as well. So I can write it as 2 over 1. Now what I can do is I can multiply these numerators, multiply the denominators, and then simplify if needed. 2 and 7 are the only 2 numbers that would multiply together. So 2 times 7 is 14, and then I'm just going to stick on that square root of 3. It doesn't actually multiply into the 2 or the 7. In the denominator, 1 times 3 is 3, so we have our answer for side A. So remember, I was doubling my side to find the hypotenuse, so side A is this 14 root 3 over 3. Okay, now I have some good news. If you look at this triangle right here, what you will notice is that this triangle on this side is actually a 45, 45, 90. This was marked in the picture. I forgot to mark this corner. This was given. See, it's a right angle also. Okay, so this is a 45, 45, 90 triangle. The reason that's good is because in a 45, 45, 90 triangle, the 2 sides, the 2 legs are congruent. So whatever we get for this leg, this other leg will have the same value. We know what this side is. We can now fill in that other missing piece. So remember, we just found this side. It was 14 root 3 over 3. So that means this side is also 14 root 3 over 3. All we need to find then is side Q, the hypotenuse of the 45, 45, 90 triangle. So let's go back to our little relationship here. We've got those two. This one is going to be whatever x was times the square root of 2. So whatever x is, that would be this 14 root 3 over 3 times the square root of 2. And that's going to be our side Q. We're going to do this similar to how we did the one over here, where we multiplied the 2 times the 7. But this time, we don't have a number outside of the radical. We have a number under the radical. So we're going to multiply what's under that radical. 3 times 2. 3 times 2, think about that, is 6. 3 times 2 is 6, and I'm just going to bring down the 14. In the denominator, 3 times 1 is 3. Reduce if possible. 14 and 3 do not reduce, so our answer is complete. And that would be side Q. Just verify that you have answered all pieces. It looks like we have all of the side values, so this one is finished. There is only one of these questions in the assignment. I know that these are difficult. This is not intended to be an easy problem. This is intended to make you think and to practice these different side relationships. So definitely give it a try. It will make you think a little bit, so don't worry if you do struggle with it a little bit. These are supposed to be a little on the difficult side. Here is your assignment set for these problems. And when you look at question 31, I'm a little worried that you may go, wait, how do I do this one? This one looks different than the examples. So I wanted to point out, when you do question 31, this is your angle here. Even though this side doesn't have a parenthesis, alpha is your angle. So when you set this question up, this is the very first problem from your assignment, you will write alpha plus 10 equals 90, and then solve just like we did all the others. So just because you don't have a parenthesis doesn't mean you don't have an angle. Your angle is just whatever is sitting there, whether it be alpha, theta, or beta, or etc. All right, have a nice day.